Hey Kevin, hope your fishing trip is good. We are back on our review paper. Maggie says show up. This paper, is it in the screen?
A little bit.
You have it, and we were asked to do 1 through 8. So we are picking up with number 3 just to check our work. And so you can show me your work when you come in, Kevin. Yep. Just how far did you get?
So I didn't get 7 and 8.
Okay. All right, so let's see. We're looking at number 3. If we're trying to determine the relationship between these two variables throughout the world, is the slope you provided in part A a statistic or a parameter? And just as the alarm went off, Ryan has said a parameter. So, and is there anyone who agrees with him? Is it a parameter?
I agree with him, but I could not justify.
Okay. All right. So the rest of you are statistics, or I don't care. So let's see. The answer is because the B, that little old B sitting there that you grabbed from this chart. Haley, remind me, what was the B in this chart?
Oh, like the number?
Yeah.
It is 0.02268.
Right, and we were looking at cigarettes per person annually and comparing that to annual deaths per 100,000. And the number, the slope number that this little old measly chart with 14 random countries, it came up with 0.02268. So that, my dear, because it's coming from a sample, is a statistic. What we're trying to do, we're trying to take it and infer something from it. We're trying to use it for inference to figure out what beta is, but we'll do a test or we'll do a confidence interval from there to zoom in on the parameter. So we're going to use that number to get the parameter. But do you see that is not the parameter for the whole world, because we got it from just a one sample experience.
So it is a statistic?
Okay.
It is.
Well, like, so
Is
then,
this from one?
on the opposite end, like, where would you say it's a parameter?
If somehow you were told that this is beta for the whole world, or I guess when you do a test, you can zero in, well, the parameter is greater than this number, or less than this number, or in this interval, then we can say it's the parameter. So if you've done a test or a confidence interval, then you can say you have at least zeroed in closer to the parameter. So, but what we had is a statistic. Do you see why I'm saying that? All right. Based on the information given, what are we supposed to do? We are doing liner, I suppose. What other information? So as you went through that, did they have linear data? Was the data linear?
It was a residual, so it wasn't really.
It might, yeah, because it was equally distributed on both
Right,
sides.
right. It is linear data. How do we know? Because one of the best ways is to look at a residual plot, or one of the ways. The best is look at the data, but since they didn't give it to us, a residual chart, if it's equally scattered, that's pretty good. If it's equally scattered,
It's not equally scattered.
No,
There's
not.
5 above and 8 below. Or
Five,
something.
Yeah.
6, 7,
It's
8.
not
Yeah, I don't
even
care
close.
about above and below on
Well,
this
now that
one.
is, what do we
Just
care about?
This isn't the
scatter.
variance.
This isn't equal variance. This is just scatter.
Isn't that what
That's-
E is equal variance, though?
Pardon?
We're doing
We're not.
We're not on
We're on
E, we're on L.
So we don't need a scatter plot. We can just determine it from that graph. If it's just
Yeah, a residual plot of linear data is scattered.
Wait, why would
It doesn't
scattered,
get much scattered. It doesn't get much more scattered
why
than
would
that.
scattered make it linear?
That's just the way residuals have to be.
Oh, because the
Residual-
line is made in between all of them. And it would
What's
be-
that?
Okay.
I mean, I can go back and reteach that, but it would take a while.
No, I
All right.
know what you're
So a randomized, make a note of that because it'll come up on your test in some way. A randomized residual chart means data is linear. Then we went on to independent, and we had, what, 14 countries, so 14 times 10 is 140, less than the number of countries? I believe so. So it passes the 10% rule, and you may check it off. Now, when it comes to n, would you guide us in your thoughts for, remember that n stands for normal residuals. So Morgan, do we have some information to look at?
So, we don't have the data, but we have the residual graph.
Yeah, but what do we have to look at?
You have to look at the histogram.
Right, so we don't have the
You can't do
histogram,
that.
and we don't have the actual residual numbers to make a histogram out
Right.
of. So, but there is another place we could look. Do you recall, Morgan, where else we could look?
What's the other graph we use other than a histogram?
I'm sorry?
Dot plot.
Is it a dot plot, the one other than a histogram? Because we haven't worked
No.
with histograms that much. What is
It's
it called?
bottom right. Is that
Yeah.
bottom right one?
Yeah, so this is called a normal probability plot. Normal probability plot. And Maria, do you remember what that's supposed to look like if we have normal, a normal distribution? And you can tell because when you look on your calculator, what's the picture look like in here? Do you recall?
Is it
Like
a straight line?
It is. So you have like data very thin. If you look in that picture, it is a straight line. So a normal probability plot, we met in chapter 2 and we learned that if it's straight, that means the data is normal. So if you have the residual data and you can put it in your calculator and see, hit this button and it's straight, then you know that it's normally,
But we
it's a
don't-
normal distribution. We don't have it. And the whole question is, if you do not have enough information, indicate what other information you would need. So right there, star the n, we do not have enough information to tell if the residuals are normal. We have to have a list of the residuals or a list of the data where we can calculate the residuals. So, you okay with that, Morgan?
Mm-hmm.
All right. Equal variance. This one. Now, Andrew, where do we go for equal variance?
The
Equal
residual
yeah, it's
plot.
equal variance of the residuals. So we
Okay.
can look at the residual plot. And this one, would you say there's just as many above as below?
No. I did all of liner, but if it failed n, would you need to keep going?
It doesn't fail and we just don't have the information.
Oh,
Well,
okay.
yeah, right. This one, it perhaps.
Okay. But it
If
fails
we get to E, that's pretty questionable.
Yeah,
So
I
we
know.
use the same graph for L and E. Because if it does pass L, then it wouldn't pass E if we looked at the same exact graph. Because if it's scattered, it's not going to be.
No, it can be scattered, just has to have the same number on top as below. They
Right.
don't necessarily have to be, they don't have to line up.
Okay, so our graphs for L and E are the same.
Yeah.
Okay.
Now the question though, here's the thing that they want not to happen. Oh, bless you, bless you, bless you. They do not want, when you're looking at that residual chart, they do, like say you have some kind of scatter around low values for X, and then it gets real scattered around Y, larger values for X. So X, say, is X is 1, 2, 3, 4. And I put that, I remember describing this to Joel on the video, but remember, if it goes like that, that's a clear no for this category. So when they say equal variance, they just want to, one of the main things they're looking for is as the X values get larger, the spread doesn't get larger. They do not like that. So that's one thing that I do see that they always fail. Otherwise, this thing about just as many X's above and below, they almost pass everything. So I know if I look at that, is there an equal spread at each X above and below? I don't know. I see more below than above, don't you?
Yeah.
All right, so I will give you some guidance if one comes up on a test. Okay? All right, because I am not real clear at teaching that well. I've read it over and over. I've looked it up online, and I know that this is a bad thing for this. As far as this graph, they're saying it passes, but I don't think it does. So I put a question mark there. Random, it did mention random. All right, number 5, assuming all conditions have been met, interpret a 90% interval. So we are going to grab our equation, B plus or minus T star. So Bree, can you guide us to B?
Yes, so that was on our
chart.
Alright,
It's 0.02268.
alright. And where do we go, Bree, for the T star?
So we find our degrees of freedom.
And how many is that?
That's going to be 12.
Right,
And then so we go to our chart table B,
right.
I think it is.
Anyone need one? I have a couple.
And then go to the 90%
Alright,
column, and then go up to 12.
alright, and what is it?
1.782.
Exactly. And where do we get SE of B?
So I think I got mine from the chart.
That's correct.
So the SE coefficient, one that lines up with cigarettes, it's
Right.
0.01926.
Right.
I plugged that in.
Alright, so that's SE of B. Did you get the same numbers as she did? She is correct.
Yes.
Alright, so when you flush those through the calculator, what did you get?
I got the interval is negative 0.012, comma, 0.057.
I
Alright,
got 1.782. I think Morgan did too for the T star. That's only there.
1.78.
I got 1.782.
I think this is 2.
I got
I'm sorry.
1.782.
She said 2, I think. Is that what you said? I think that's what
Yeah.
you said. Sorry. Okay, so that is our, and so we're supposed to interpret that. So we say, we are 90% confident that the true slope of the regression line, and that's for the whole population, is in this interval. All right. On number 6, if you were to perform a test and they gave you beta is 0 and beta is not equal 0, they gave you alpha is 0.0, what would you conclude? So they just want you to do the test. So I'm not sure why that was confusing. They give you the p-value, they give you the p-value. And then the second question, so let's just perform the test, ignore the second question. So, Haley, do you have something to add?
I'm young.
Okay, all right, Maddie. So tell me, looking at the regression, the mini tab for this one, we don't even have to do any calculation. What number do we need to do the test?
T,
All right, and what is it?
1.18.
All right, 1.18 is it goes under the T value.
T and then cigarettes, right?
Right, but we want the p-value to compare to alpha. So we want to know p greater than or less than alpha. This time they said alpha was, what was it, 0.1, so that's odd, but that's okay. So 0.1 is our alpha, but all we need is p, Maddie.
Oh.
You could take t and go to the chart and find p, but they gave us p. And not only, if we went to our chart, we'd get an interval. So this is better. This is exactly p. So what is the p-value?
0.262.
And that's only true for two-sided tests. Remember, mini tabs are dumb. They only know two-sided p's. So is this a two-sided question, Maddie?
Yes.
It is. So when it says beta is not equal to 0, that's two-sided for HA. So that means our mini tab is correct. If it had said beta was greater than or less than 0, well, we would have had to take that number in the p spot and divide it by 2. All right. So back to you, Maddie. 0.262 is the p-value, and we're going to compare it to this is our cutoff value. So I noticed that our p-value, our probability of all this happening is 0.262. So it's greater than alpha. So what conclusion should we make about these two?
Hang on. We failed to reject each
Because
other?
this is not very if this was real unlikely, like it was way lower than this, we would reject this. But it's not very unlikely.
So we failed.
It happens. So we're going to fail to reject, but then you have to go on. Fail to reject, saying. So if we fail to reject, what can we say about this?
Because there is sufficient evidence.
There is
Wait, why are we failing?
No, I thought we had to make it a negative
P
when
is
we were failing
greater
to
than
reject. I thought we couldn't
It
say there's.
I thought
it
P
sometimes
was-
is and sometimes isn't.
But I thought we
But-
could never say that there's.
Yeah,
something
Let her
bad.
finish, let her finish, don't criticize it until she gets it out of her mouth. Go ahead, Maddie.
P
To
cigarettes.
If you
say,
fail to reject this, go ahead, there is,
Meaning-
saying
oh, it's
there
information?
is sufficient
So-
evidence. Go ahead, to say what,
to
Maddie?
say, isn't it H sub A is false, or like H sub O is true?
We never say H sub
Not
O is
like
true.
that's wrong.
So if you fail to reject this, what do we always say in general, and then we'll make it specific to this problem. If you fail to reject this, that means you're accepting it. So that means there is not enough evidence to say this. Because if you're accepting this, where you're failing to reject this, then you're saying there is insufficient evidence to say H sub A, whatever H sub A is. So if you're accepting this, failing to reject it, then this can't both be true, right? Yeah.
Shouldn't that be flipped? Like the mouth shouldn't be towards the .262?
Yeah, 0.262
Oh,
is
yeah.
greater.
Thank you.
Two hands.
Oh, yeah, thank you.
I know, I was going to my hands.
Okay, thank you. 2 hands up. All right, so conclusion the same. This is much more probable to happen than our cutoff point, so we're not going to reject it. We're going to fail to reject this, and we're saying there's insufficient evidence to say H sub A, which is, and I don't want you to just say H sub A, what? Say, what does this mean right here? There. Is insufficient evidence to say there is a linear relationship, because this is saying no linear relationship, right? When the slope is
Wait.
0,
So
that's what this is, and this is saying there is a linear relationship.
So now we're saying that there's
Saying there
Never mind.
is insufficient evidence to say that a linear relationship exists between what? I'm not going to write it all out, but can you, Joel, tell me between what 2 variables?
Between the average cigarette, the average number of cigarettes and the deaths from coronary heart
Okay.
disease.
All right. Did that match your thinking? Questions on that? Remember, fail to reject. Now, Haley, back to you. What if we had said, we're going to reject this? Saying, what would we say that time?
There's sufficient evidence.
There is sufficient. So sometimes we say insufficient and sometimes we say sufficient. It always points to this, whether we're going to say it's okay or not. So if we fail to reject that, we say there's not enough evidence, insufficient evidence to say this, which says there is a relationship between the
And if we
two.
reject H sub O, that there is sufficient evidence.
Right, right. That's not new, so we keep hitting that wall over and over. Are you banging your head against that wall still? All right, okay. It should make sense at some point, but if the cloud is not lifted, memorize it. It'll get you through it. All right, I don't like my math monkeys, but I can push them through the test. All right, other questions about that? Change yours if it needed to be. Justify your answer. Looking at now the second part of the question is, so one thing, when you hit this question, I don't think you should say, I don't know what to do. You should know how to conduct a test. The second part of the question is, what does that agree with part 5? So I think that was your question, Bree. What was the number? Oh, it's still up here. Is this it? Yeah.
Yes.
All right. So does this resolve saying there is insufficient evidence to say there's a linear relationship? So we're saying we're not rejecting this. Does this correspond to what we saw here? That's what they're asking. And if it does, how? Can you put that into words? Shannon, what do you think? How does saying this confirm this? They love that relationship between tests and confidence intervals. So this is saying beta is 0. That means there is a flat line. There's no relationship between the two variables. And here they're saying the slope between the two variables is somewhere between this number and this number. So what magic number does that include?
0.
0. So 0 is in that interval, so they coincide with one another. So those are saying the same thing. 0 is a possible value for the slope, which is what we came out with on number 6. 0 slope means no linear relationship between the two. It was a plausible value in step 5. It confirms your test in step 6. Do you see the relationship? All right. Number 7. All right. Is the least squares regression line an appropriate model for this data? Is the least squares regression? Justify your answer. All right. So what are we looking at? They gave us a mini tab. Can you scan that, Dan, and tell me what the two variables we're talking about on this number 7 and 8? Sorry, it's right on that page.
What we're looking for the equation?
Yeah. So what kind of variables are in this one? Like the last one was cigarettes per 100 people or something like that. So what are the variables in this problem?
This is detergent and time.
All right, so we have time, and they blopped a thing of detergent in the water, and they're looking at the area of the drop as it spreads over time. Okay, so I always give myself at least this much before I do any problem. I just kind of capsulize it visually. They're talking about over time what's happening to the area of the drop of detergent. So assuming it's going to be getting bigger, I'm expecting in my stat gut something like that. Could be wrong. All right. So, and then we're looking at a residual plot. They didn't give us the plot of the data. So, from that plot, we're supposed to determine is the least squares regression line that this mini tab would give us, it's going to cough up a least squares regression line, would it be worth its salt? What do you think, Dan? Looking at this residual plot, which is like this. So, does that show a healthy result for regression or not?
I don't think so.
Right. Because what's it supposed to look like if we have linear data?
Scattered.
Right. And we see a clear pattern here. So therefore, the question is no. The answer is no. The residuals show a curved pattern. So for it to be a proper regression line, it should have linear data, which would mean a scattered pattern. So this is definitely not scattered. Can you write that in your own words? And wherein was your confusion? Let's see. Maggie, can you explain what was confusing you?
Oh no, I was fine with this one.
You're
I had
fine
this
with
one.
this one?
Yeah.
Joel, was it you?
I knew that it having a distinct curve in it was
Not good.
the reason that it wasn't appropriate, but I couldn't I wasn't certain of that.
Okay, so just say no, it's not a good model because the residual shows a strong curved pattern.
Okay.
All right. So anyone else have more confusion about that we need to discuss? All right. So then it goes ahead, even though it's not a good regression line, it asks you to make up the regression line anyway. So we're going
That's what I was asking?
yeah, it says use the model to predict the area covered by 5.5 seconds. So even though it's a bad model, they're asking us to do it anyway. So who's going to?
I thought it just meant look at the.
All right, so go ahead, find your A
I
and
thought
B.
that at first too.
Find your A and
I wanted us to
B.
do some kind of transformation.
Yeah, I would see that as because that's what we've been studying.
I knew it was too easy of an answer, but I just went to 5.5 seconds and went up, and it was -3, so I just said negative.
Okay.
I wrote the formula down, but I was like, if it doesn't exist, then why would I do it?
I know, but then I did it. I said, well, all right, and I looked it up and I got it right. So So take the model now and find your A and B and go ahead and don't transform it, just use the model that is given to you. You can't transform it, we don't have any information to transform. So, alright, so do you get a value?
Yeah.
Alright. I'll be checking it in a minute. Alright, can you tap that out? So, no calculator. Alright, is mine floating around or does someone get it? Alright, that looks good. Good, alright. Alrighty, so putting in the value, I see people getting out something around 12.5 or 6. 12.5. So check your, what were the A and B for those? Maggie, could you give me those?
A was negative 4.133
And then the B?
is 3.0333.
And you're plugging in the 5.5 for your X variable, and it comes out to area equals 12.55 or something like close to that. And those are centimeters squared. Uh-huh.
Could I make a quick copy of more notes from when I was Southern?
Certainly. All right. All right, so now we're on, I'll read the question and give you a moment to respond. If you find that I'm waiting too long, just go ahead and do the next one. Number 9. Based on the residual plot, do you expect the prediction you made in question 2 will underestimate or overestimate the area covered by the detergent? So we made an estimate. So now do you know how to use the residual plot to answer that
No,
question?
question 2, does it mean question
I think
8?
it's 8 or 7
Yeah,
or 8.
sorry, question 8.
We way yeah. I think we underestimated.
Yeah, we,
The prediction line is,
Definitely under.
This is guys, this is residuals, not the actual
We
Yeah, this
answer.
is
overestimated.
residuals.
we overestimated?
This
Yeah.
is residuals.
No,
Guys,
don't
this
use
is
12.
residuals.
Yeah, that's.
You don't use 12
Yeah, I
at all.
think it has to
This
do
is
with the
residuals.
dots.
Yes.
all right, put down your answer and I'll explain it in a second.
It's down
So
earlier.
Kev,
No idea.
we're working on number 9, which refers back to the
If the
previous
line is
problem,
above
not
the dots,
question
then
2.
overestimate.
All right,
Over the dots,
I copied these from several different exercises, so it got kind of confused there. So on number 9, Kevin, it says, based on the residual plot, do you expect the prediction you made in question 2? We meant the previous question, question 8. So, change that. All right, so looking at the residual plot, this is your prediction line. Remember what a residual plot is. Originally, we had some data, and we had a least squares regression line, and we had residuals. And what we did is we took that and we bent it so that this line is straight, so we can clearly see the relationship above and below the line. So these are the residuals. This is your prediction line. On a residual plot, it's the straight one. So on 5.5, where does that bring me on the board? Almost to the lowest point, doesn't it? About right there? 5.5. So it brings me to that spot right there. These are my observations. This is my prediction. So the question is read, will your prediction be an underestimate or an overestimate? So here's your prediction. It's way above what the data actually showed at that point. So the prediction was above. The prediction is an overestimate.
You don't use
Wait,
12
what?
at all.
Yeah, you just use 5.5.
Just because the
This is the prediction line.
Why is
This is what we observed. So your
this
prediction line is
what we're
over it.
predicting, and the dots are what's observed. So if we're
5.5.
predicting at a certain point down here between these two, then we over predicted because that's what we observed.
Why are we using 5.5? That's what I don't understand.
Oh,
That's
okay.
It says go back to question 2, but it meant question 8.
It has to do with
Yeah.
the
It's the second one.
So it was like, hey,
where
use
the dot
5.5
is.
and
We
then.
don't use the 12 at all?
Right.
That has nothing to do
Well,
with this?
At
No, the 12 has
5.5,
nothing to do with it.
The 12 is
this
sitting
is where your
right here.
prediction was, and this is where the pattern.
Okay, got it.
So
That's not
you
12.
overestimate.
No, it's 5. It's
The 12,
5.5.
you're not going to use the 12 for 2 reasons. One, because
that's the 12 is right there. That's your prediction line.
Yeah.
Oh, that's not 12 on the
It's 0 on the
0 because it's a
Wait, what?
residual. It's the difference from the prediction line.
Okay, so the 12
any-
is when you.
Yeah,
which means
right.
this line was over.
But can we not use it because it has a curve?
Yeah, we can't think of a residual as like a residual plot as.
I'm sorry?
Can we not use the calculation that we did to get 12.5 because
Right,
it has a curve?
Right, but then
They're like,
said-
hey, pretend it's normal.
Okay.
all right, but
So
we
if-
could answer that question, Joel. We still could answer that question.
Right.
Right. We could base on, these are all the values that our equation, the A and B equation, this one, would
Yeah.
give us. But in observations, the residual was way below it, so
Right.
the prediction overestimated. It was way up here. So if your residual was up here, you would say your prediction was an underestimate. All right, number 10.
On a test, if I just explained like the pattern shows where 5.5 should be and it's not on the, like it's either above or below the line, that's fine for justification for the answer.
Well, you just have to say if it's an over or under prediction.
Right, but it says to justify it
Yeah, you justify it because,
because the pattern shows.
yeah, because the pattern showed that it was under the line or above the line.
Yeah.
Yeah, exactly. All right, number 10. All right, below are residual plots. So we've got 2 of them. So notice the first residual plot is made up from a set of data where there was 1 log. See where it says log versus time? So circle log on that one. On the model 2, you see there's 2 logs. Circle both of them. That's the kind of thing you're going to be looking for when you're dealing with these problems. All right, so find a spot where there's 1 log and where there's 2. Yeah.
What happens if, is there ever gonna be a case where we try all the options, like cube root it, log it, and it doesn't ever
They
make it
pretty
linear?
much do the transformations for us.
Okay.
So we did it just so we could understand what they were doing.
Okay.
So I say that and then it shows up, but to my knowledge, no.
Okay.
Okay. Below are residual plots and the computer output, the mini tab. Which transformation produces a better model for the relationship? So all you've got to go on are the residuals. So which one is showing a healthier model? So Ryan, look at the 2 maps, model 1 and 2 of the residuals. Which one is healthier looking?
Model 1,
Why? And that's correct. Why?
because there's more on each side of the line.
Right, it's more scattered because do you see model 2 shows a pattern? Yes.
What I was gonna say is it an appropriate answer if it's because the standard error is less in the first one?
Not really. They're looking at the residual plots. It says that's why they gave them to you.
It's
So
more scattered. That's what we're answering.
yeah, we're looking for more scattered. Do you agree that it's more scattered in model 1?
Yes.
All right, so model 1 is better as it has a more random residual plot, a more scattered one. So do we have to go off of that? Yes. Use the model you chose in question 4, which is really question 10. Kevin, do you hear that?
It's like an essay question.
Yeah.
Okay.
To predict the area covered by detergent at 5.5 seconds. So now we're gonna use a healthier model than we did earlier. So do you know how to get that? We decided to use model 1. So go to that mini tab. See if you can grab the model. That means the regression line, and solve it again with 5.5. See if we get, what did we get before, like 12?
It's A plus BX, right?
Yeah, so it should be way different, because that first model was so bad. So I'll jump in a minute and have someone tell us the regression model to use. this, it's an LOG.
How do you?
All right, this is the one. So again, I always draw a little sketch for myself. This is the one that straightened the data out more than the other. It involved time and LOG of the Y value, which in this case was area. So. All right, so Andrew, can you get us the regression line?
I think so.
Okay.
Is it log area
Uh-huh.
equals 0.34057
Yay. Uh-huh.
plus 0.115582
Yep.
times 5.5?
So yes.
All right, times
Log the
whatever
Y
our
side.
time value is, and we're gonna plug in again, what is it, 5.5?
yeah.
Okay.
Second log.
All right. Do you see where the log showed up in the regression? The only way you would know that is looking at the residual and seeing that they took the log of area to straighten it out. So you didn't have to straighten it out, but you had to know what they did to straighten it out.
Wait, so you do 10 instead of E?
Yeah, uh-huh.
Oh wait. This how?
What's this thing on this side? I might have that number.
I got 0.976.
I rounded a little bit differently.
Why'd you do that?
Yeah, 9
I
point,
just-
0.976
I did
is the
0.34.
first thing that you should
Yeah, I'm
Yeah,
talking about.
1.12.
So
at the complete.
0.976 is what I got for before logging or anything.
I got 1
Me too.
yeah.
No.
What?
So if you have
because I did
log
0.34
Y,
and 0.12.
is
I didn't
equal
I
do
just
all those
rounded
numbers.
them.
say 2.
All right,
In order
so
to get
That might alter it a
Maddie,
little
what'd you get on the left?
You're gonna
I mean, the right?
I got 1 because I did 0.34
each of
and
the
0.12.
All right, anyone get a few more
I got
decimals?
0.976.
Yeah, I got
That's what I got.
All right, Maddie will be close.
is equal to
It's just a
All right,
E
so
raised
this
to
was a
2.
little different because it's not an ln.
So
So
E will
to
log- E log
exponentiate,
cancel
we're
each
going
other.
to use 10.
So then you'd have
So-
So,
Yeah.
is equal to
Ellen does Ellen not work the same?
Use 10.
Yeah, you have to use a 10.
because
It's not
log is a
LN.
base of 10.
Log is
Right.
base 10.
Yeah.
LN is E.
Yes.
Yes.
Log is
And
10.
it's-
Okay.
It's
Second.
All right, I don't have that number.
It's on-
Somebody? Can you share it with me?
9.4.
9.4?
Or 9.46.
Or
yes.
9.46. Yeah.
I just did a whole line.
So how did that compare? What did we get when we used the crappy model? 10? I mean 12?
Yeah.
12? 12-ish?
Yeah.
All right, so this is zeroing in. It's a better model.
So for this,
So
Question?
nothing, sorry.
All right.
it'll
But you
never
can
have
look-
a log of x-axis just alone. Like sometimes it'll have
Oh,
both.
the double when it's a double,
Yeah,
but
but
never
alone.
alone.
Okay.
Right.
Would you rather us take all of those decimal points? Would you take points
Yeah,
off?
the more you take, the better, but I probably won't be picky. What's yours come out to be, Maddie, with 1?
Oh, I.
It's just 10 to the first, so it's 10.
Oh, yeah, that's right. I could do that one. Okay. 10 to the first. Yeah, it is. But if you just show your steps, I'll probably take any decimals, but the more you take, the closer it'll be to my answer and the safer you'll be. All right, number 12. Moving right along, sorry there's a big space there, I was putting several packets together. So number 12. All right. We have a scenario where you have the number of fish. This is in honor of Kevin, who's on a fishing trip today. So we have number of perch. As that goes along and increases, we were wondering the percent of those perch that are killed by predators. So were you wondering about that relationship?
Yeah.
I
Absolutely.
thought so. So therefore, we created a mini tab, and I want you to try to find your test, at least I think in one of the multis, uses this phrase. See if you can unravel it. Find the standard deviation of the slope of the sample regression line. So see if you can unravel what they're asking for.
Can I ask a question?
On that one?
Yeah.
Uh-huh.
Is it SEB?
Is it
Is that
what?
what that is? SEB? Is that SEB?
Alright, yeah, that's what we're gonna answer.
That's what we're looking for.
That's what we're
Alright,
solving.
so try everybody think that out, and,
That's right.
alright. Number 12, yes. Do we look where we normally look for SE of B? And the answer is yes. So the note I want to make is the standard error of the slope is what we normally call it, but it is the standard deviation of the B's. So standard deviation of a sample. Remember, B comes from a sample. So we have renamed that standard error, but it is the standard deviation of the values from a sample. Joel?
Would you ever give us one on the test where we don't have a mini tab for that and you'd have to calculate it?
No.
Like the homework.
No. Yeah.
So for on the mini tab, this is just a question about comprehension.
Yeah.
For the SE coefficient on the for the constant, like, and the P for the constant, what's the relevance of those numbers?
Where is that?
So we use these three numbers
Yeah.
or numbers sometimes, but what's the relevance
That's
of
what you
this?
do in regression around alpha, which
We don't need to
give
use.
y the y-intercept. So it's a lot of times it's meaningless anyway.
So we're not using it.
Right, we're not using it. Okay, so Andrew, what is that number in this case?
Is it .002456?
It is.
No. I mean,
All right,
I meant-
can you find it?
I meant the old one.
Will you be flexible?
Yeah.
Notice,
I
on this mini tabs are very different from one another, so you have to be good at going from one to the next. This one, they called it standard deviation. Let's look at a previous one that we've used. What else do you see that column called? Andrew, what else?
Wait. I'm sorry, what?
So we just looked at this on
Oh,
number
it's called
12.
standard error.
It was, yeah, where else? Standard error or what? Where else do they call it?
Standard error coefficient.
Yes, SE coefficient. So can you be flexible enough on the mini tab to accept it as standard deviation or standard error coefficient?
Yeah.
All right.
Yes.
All right, make a note of that if you're think you might lose that
Wait,
flexibility.
they're the same or they're okay?
This class has made me make an acronym for everything because we literally make acronyms for so many things.
Now you just do it.
They're less helpful because we have so
I
many.
wasn't sure if you were being
It's
serious
true.
or not.
Bits, bins, what else? Liner,
Rin.
Rin and Rill.
Real. I
It's like
know so many.
All right.
Jurassic Park movie.
Okay, we're going to do a test. So let's see if you can, before the bell rings, conduct this test. We're going to do the test. Let's assume the conditions are met, so we don't have to go through liner. For alpha equals 0.05, establish a test and make the appropriate conclusion. Now, on number 6, you said we couldn't do that last night, but hopefully this will make more sense. Can you use that mini tab and run the test?
Are we going to make it double-sided?
Whatever, yeah, let's do that. Let's do everything, do the same test. That'll make it easier. Beta equals 0 and double-sided. So this not equals. You'll have the problem, will have to guide you to that, but since I didn't write out the problem, I'll tell you. So we'll do a double-sided, so our mini tab will match our work. Most of the time they do that, they're pretty kind about that.
So we don't actually have to do the work.
No, yeah. So, before you leave, show me if you're going to reject H sub O or fail to reject H sub O and the remaining statement. And that'll be your ticket out of here. So, have anyone got it for me?
Wait, can I just read mine?
I can read it.
Can you read mine? Yeah.
Yeah.
I really want to figure this out.
I know you do.
I've been making me so mad.
I get so mixed up with
Yes?
rejecting.
Yeah. The only thing is, I want you now to apply that to this situation.
Okay.
To say, you say there is a linear or is not a linear relationship between these.
There is.
Because this is
This is yeah.
all right, you're out of here.
Yes.
Maddie's
Does anyone
gone.
know which equation?
All right, Kevin.
You don't need an equation.
You're comparing.
I want you to finish this handout, Kevin, so you're going on to 21. So, for homework, and we'll finish that up on Monday, and we have some multi-practice, and we're testing on Tuesday. So Kevin, goodbye.
Bye, Kev.